Hello everyone. This is one of the challenging problems from the Additionals Mathematic book IGCSE. In this problem we are supposed to find the shaded area which has been shown in this figure in blue color. To solve this problem we need to take some steps. The first step is to analyze this figure and extract the information from the problem. And then also we need to find out what this figure is made up of, what other figures. Next, we will have a review on the lesson, the main points of the lesson prior to this challenging problem to apply that knowledge and that main points to solve this problem. And next, we need to get help from another equation and use that equation to solve this problem. Okay, let's begin with analyzing and extracting information from this problem. So as you see, a circle is inscribed inside a square of side length 10 centimeters. That means each side of this square is 10 centimeters. That means the middle of this side is exactly corresponding point to the center of this circle, and that again means that this circle has a radius of 5 centimeters, right? So this is information provided by the problem. And also if we look carefully we will see a quarter of a larger circle, as we can see here. Let me draw it to make you understand better. And this is the center. This larger circle has a radius of 10 centimeter, right? And this larger circle intersects with the smaller circle in 2 points. Let's call them A and B. Name them, these 2 points, okay? So this is the information that we can get from the problem, okay? And also I can connect these 2 points to the center of this circle. And as you see, I can create a sector. And also I can again connect these 2 A and B points to the center of the larger circle. And make another sector, right? So now let's try to understand what this figure is made up of, what other figures. Let's have a look at here. We see in this figure, this is a sector made by a smaller circle, so let's call it R, which is 5 centimeters, right? And here, larger R, which is 10 centimeters, capital letter R, which is 10 centimeters, okay? These are 2 sectors. Now, if I take this yellow color sector and put it so that it will overlap 100% with this blue color sector, then you will see that there is a part left and the blue part is left. So that means if I can calculate this area, the blue one, and if I can deduct this yellow part from that, I will get what I'm supposed to find here. I will be left with this blue part, right? So this is how we can solve this problem. Again, one more time. If I overlap this 100% so that it can cover it, the blue color sector, so you see that if I deduct the yellow color sector from the blue color one, I can get the part which has been shown in this figure, right? So let's continue to solve this problem, and also we need to have a look at the main points of the lesson prior to this problem. So in the lesson, we have learned how to find the area of a sector. And that is the formula how we can find the area of a sector. A half of r squared times angle, the angle which is here, shown here. And this angle must be in radians, right? It must be in radians, otherwise the answer will be wrong. And also we have learned that in order to find this area of this triangle, right, we need to use this equation, a half of r squared times sine theta, sine of this angle. And here sine of this angle can be in degrees or can be in radians. It doesn't matter because we are dealing with the sine of theta, not with the angle itself, right? So you can put degree here. The answer will be the same. And also we have learned that if we deduct this area of a triangle from the area of a sector, we can calculate this area, the blue color area, and we can calculate here, right? So that means if we deduct the area of a triangle from the area of a sector, we will get this blue colored part, right? And also we need to use another equation, and that is law of cosines, to solve this problem. And law of cosines shows the relationship between the sides of a triangle and the cosine, the angle we need to know in order to solve this problem, right? Now let's get back to the problem and see that what we have got. So let's call the center of this circle O, and then here is 5 centimeter, the length or the radius of the smaller circle, and here we have the radius of the larger circle, which is 10 centimeters, right? And let's call this angle theta, and then let's name this one as beta. And then we need to follow the approach. We need to first of all find the area of this sector, okay, and then deduct the area of a triangle from that, and then get this blue color area, and then do the same thing to another sector made by the larger circle, and deduct that part from the blue color one, right? This is the approach. Now let's begin. So in order to find this angle, let's begin with angle theta. I'm going to find angle theta. What is the value of angle theta, right? So I cannot directly use this equation because I need to know the sides, and I don't have the one side here, and that is AB. I do not have this AB, the value of this AB, right? I don't have it, and that is unknown to me, so I cannot directly use the law of cosine. So therefore I will try to connect this vertex of this square to the other sides of this square. Okay, so let's suppose this is at the middle, exactly in the middle. Now I have here theta, a half of theta, and here a half of theta, right? I have the value of this side, which is 5 centimeter, and I have the value of this side, which is 10 centimeter. And here I can find the value of this side, and how to find the value of here, which I can use the Pythagorean theorem. I have a square with side length 10 centimeter, 10 centimeters, and then I want to find this length, the length of this side, okay? So using Pythagorean theorem and divided by 2, because we need to find the whole length here, this line. So then divided by 2, we can get the value of this part is 10 over square root of 2. So you can try to find it by yourself. If you get the answer by 10 square root of 2 times square root of 2 over 2, so that means these two are the same. I just multiplied by square root of 2 and square root of 2 to make it in this form, right? So these two are the same, the values are the same. So I found this value and just I will write it here. That means I am dealing with this case. Here is a half of theta, and here another angle which I can use the law of cosine. I can apply the law of cosine to find this angle is here, and let's call this one alpha, okay? And as you can see, the sum of these two angles give me pi, the value of pi, right? That means let's name this theta, a half of theta, this angle as pi minus alpha, okay? Now I have the value here, which is 10 centimeters. Here we have 5 centimeters, and here I have 10 over square root of 2. Then I can use the law of cosine to find the value of this alpha, and then when I find this, I can find a half of theta, right? Because the sum of these two angles is equal to pi, correct? So now I just use the law of cosine. You may compare it with the law of cosine, and then I will write. And that means the opposite side to the angle, which is 10 centimeters. This 10 centimeter squared is equal to 5 to the power of 2 plus adjacent sides of the angle plus 10 over square root of 2 to the power of 2 minus 2 times 5 times 10 over square root of 2 adjacent sides times cosine alpha, right? And then I will get 100 minus 25 minus 50 is equal to negative 100 over square root of 2 cosine alpha, right? And then that means the negative cosine alpha, because the answer is negative here, is equal to, let's negative stay on the cosine side, okay? 25 over 70.71, which is equal to 0.353, right? So then that means negative cosine alpha is equal to 0.3053. This is what I've got. But there is a trigonometry equation, and that says that negative cosine alpha is equal to cosine pi minus alpha. So this is exactly what we wanted to get, and that means we are calculating this alpha. What, on the other hand, we are directly leading to value of this half of theta, the one that we really want here. So that means we got the negative, so that's what we wanted actually. This is what we want. We want this side, okay, the adjacent angle, right? So therefore cosine pi minus alpha is equal to 0.353, and that means pi minus alpha is equal to cosine inverse 0.353, which that means pi minus alpha is equal to, which is a half of theta, is equal to 1.21 radians, okay, or 69.32 degrees. This is a half of theta. but we want theta because we are going to calculate the area here. We want theta. Therefore, theta in radian is equal to 2 times of this, which is equal to 2.42 radians, or 138.64 degrees. Okay, this is in degrees and this is here is in radians. So this is how we calculate the theta here from using the law of cosine, and then we have found theta. We have found this angle already done. We have found it. Okay. So now we have found the angle. Again, we can apply the same law of cosine to find this side, the side AB, the line segment AB. We want to find the value of this. Let's name it or call it X. Okay, let's call it X. Then we are dealing with this case. We have a triangle. And here is the radius, 5 centimeters, 5 centimeters. And also we have the angle theta, which is equal to 2.42 radians, or 138.64 degrees. Now we want to find the value of this. Why are we going to find this value? Because we are going to find the angle of beta here, and in order to find the angle of this angle, we need to again use the law of cosine, and then we will face problem if we don't have the value of this side of the triangle. You see a triangle here, the larger triangle, AB, and here let's say O, this triangle, AOB, right? So we need to have the value of this side that we are going to find here in order to find the angle of beta. This angle. So we are supposed to find this angle. In order to find this angle, we need to first find the side, the value of this side, right? Okay. Now let's use the law of cosine and find this angle. So I just write directly, I just write the value directly. I don't write the formula. This question mark, or x, let's say x is equal to square root of 5 squared plus 5 squared minus 2 times 5 times 5 times cosine theta. In theta I can write both. I can write degrees or radian, doesn't matter. So I choose radians. It doesn't matter actually, because it will give the same value, 2.42 radians. But I need to write radians because in our calculation, by using calculator, we need to be careful. Do not make mistake and write and put degrees, so the answer will be wrong. So make sure this is in radian, or if you like, you can just write the value of 138.64 degrees. This value, you can write it down. Okay, so by solving this, we will get the value of x 9.35 centimeters. So this is the value of this side. Now we are done. This is equal to 9.35 centimeters, right? So now we can find the value of beta, the angle of beta, and that is Here is the larger triangle here in the figure that we draw. A, O, capital letter O, B, the large triangle, okay? This is the larger triangle, this is the smaller triangle in the smaller circle. And here the sides are 10 centimeters, 10 centimeters, and here is 9.35 centimeters. Now I can use the law of cosine and I can easily find the value of this angle. So, right? 9.35 is opposite to the angle, so I need to write it at the beginning here, one side of the equation. 9.35 squared is equal to adjacent 1 to the power of 2 or squared plus 10 to the power of 2 minus 2 times adjacent sides 10 times 10 cosine beta, okay? And then from this equation I will get cosine beta is equal to 0.562, which if we get arc cosine or inverse cosine, we will get the angle, the value of angle as beta is equal to 55.74 degrees, right? 744.744. So this is the value of the beta angle, and then we have found that. So therefore we are able now to calculate these two areas, right? Now we are able to calculate, because now we have this angle theta, which was 138.64 degrees or 2.42 radians, and also this beta that we have found, which is equal to 55.744 degrees, or you can use calculator, which is equal to 0.973 radians. Okay, this is the value in radians. So now we have the radius, we have the angle, values of both, and then we can simply find this area, shaded area, by using the formula that we have learned during the lesson prior to this problem. Okay, so the problem is already solved, almost there, and the area of a sector, which is, let's see, let me write here the area of sector by R is equal to 5 centimeters. Okay, this area, I'm going to directly find this area, is equal to the area of a sector, a half of R2 theta minus a half of the triangle, a half of R2 sine theta, right? Which will be equal to a half of 5 squared times 2.42 radians minus a half of 5 squared sine, we can put radian or we can write the degrees, doesn't matter, there is no difference, 138, I will write the degrees, 0.64, okay? And then the answer here will be equal to 22 square centimeters, right? So we will do the same thing for the yellow part, the yellow color sector, okay? So again, I will write the area of sector by R, 10 centimeters, which will be equal to a half of, again, the same formula. I will only write the numbers, plug in the numbers into the formula, 10 to the power of 2, the radius, times, angle must be in radian. Angle must be in radian, okay, this beta. Zero 0.973 and minus, I need to deduct the area of a triangle from that, and it is a half of 10 squared times sine 55.74 degrees, or you can write the radiant one, but you need to be careful how to use the calculator not to get the wrong answer, because mostly calculators you just put on the degrees, not radians, okay? And then it will be equal to 7.33 square centimeters, right? So now, as we said, we need to deduct this yellow color one. So this is yellow color area from this blue area, and then we will get the final answer. So therefore I can write finally the shaded area is equal to 22 square centimeters minus, we need to deduct the yellow one, 7.33 square centimeter, which will be equal to 14.67 square centimeter. Okay, so this is the final answer, right? And here it is. So we finally found the area of this part, the shaded area, right? Okay, the solution was long and we jumped some parts, so hopefully this video was helpful to help you understand how to solve this problem.